All right, everybody. I'm going to go ahead and get started. So, good morning and good afternoon. My name is Lisa O'Brien, and I've been hosting this webinar series for the last year and a half. Today, I'll be handing the host and moderator baton to someone you may recognize from past webinars. So, if you've been with us before, you may recall Jose Hotema as one of our guest speakers. Jose has been with us at Plus One for almost 3 years, primarily focusing on QA within the product department. You may also have seen him with us at trade shows and trainings as he enjoys supporting the sales and marketing side of our business just as much as engineering. So I'm not leaving Plus One, but I will be moving behind the scenes as Jose moves in front of the camera. So without further ado, please help me welcome Jose. And Jose, I'm officially handing this off to you.
Awesome. Thanks, Lisa. Hi, everybody. I'm happy to be here. As Lisa mentioned, I am an engineer by trade. However, anytime that I get to work with clients and get to explain some of our technology, I love to chat. I love to share that. So for those who don't know me, I have a background in mechanical engineering. And before I got to Plus One, I worked at Amazon Robotics doing testing up in Boston. Also, even from a young age, I have always worked near engineering. My dad has a machine shop in South Texas. So, from a very early start, I got to start working with him. And if you could say that it's both the best and the worst kind of internship experience because, you can't report anything to HR. Your HR is your mom. So I'm happy here to be with you today to introduce our 6th episode and today's guest. Today, we're going to be discussing the $60,000 minute, Downtime's hidden price tag, and we'll be joined by John Crimmins, who is a returning guest for us, and Ryan Hannon. Okay, so today we will focus our discussion around the cost of throughput per square foot, the value of every lost minute, and also the hidden cost of lost production. So before we get started, if you have any questions, please put them in the chat and we'll address them at the end. Also, today's presentation will be recorded and we'll be sending a follow-up email to everyone with the link to the recording. Awesome. Without further ado, please join me in welcoming our guests, John Crimmins, Senior Solutions Architect, and Ryan Hannon, Director of Customer Excellence, both here at Plus One Robotics. I'm going to give our guests a moment to introduce themselves, starting with Ryan. Ryan, please tell us a bit about your background and what you do here.
Yep, thanks, Jose. For you guys that don't know me, my name is Ryan Hannon. I'm the Director of Customer Excellence here at Plus One Robotics. Director of Customer Excellence has a couple different pillars underneath of it. First and foremost is the Solution Architects, which is Mr. Crimmins' role here. And that's just to make sure that we're designing solutions that will meet your ROI and also solutions that will work in your facility. We don't want to over-engineer something or under-engineer something and miss the mark. From there, kind of the projects roll into our operations team, which is a separate pillar, but then come back to me in the support function with our support team and our crew chiefs who manage our Yonder system and the remote calls that come in from our robots that keep you moving and prevent that downtime. Thanks, Jose. Real quick forgot about this. Where I was before, I was a customer of Plus One at Pitney Bowes, where we installed 14 of the Plus One systems. And then before that, I installed automation for NFI and UPS. On mute, Jose.
Awesome. Thank you, Ryan. Yeah, it's very important. Customer return employee. So Ryan has a lot of valuable feedback for Plus One Robotics from his days managing the operations at Pitney Bowes. So without any more anticipation, I'm going to bring it over to John so you can tell us a little bit about who you are and what you do at Plus One Robotics.
Yeah, thanks, Jose. Yeah, and thanks for having me back. So again, I'm a Senior Solutions Architect here at Plus One Robotics, as Ryan was saying. I'm under his team. And what I've done here for almost 3 years now, and really for my entire decade plus career in the industry, is really advising and consulting for any of our clients on how the technology applies to their facilities. Of course, Plus One really focuses on AI vision systems And so looking at how AI vision can help a customer or not help, right? We're not afraid to say, this might not be the best application for an AI system. And of course, we're going to talk today about, this, all the downtime and how we kind of solve that as well as part of a core part of Plus One Robotics. But folks can think of me as a consultant to, the sales process to make sure that the right thing is being designed into your system and to make sure there's not any over engineering happening to ensure that we can get you the most effective cost possible for your operation.
Awesome. Thanks, Ryan. I feel like that is a really important role here at Plus One Robotics, making sure that we're always delivering what it is that our customers actually need and not anything over or under. Okay, so before we get to the Q&A part of our discussion, I'd like to show the audience a short video to provide some context to some of the items that we'll be touching in today's discussion. This is an older video, so bear with me. Here's Eric talking about what Plus One refers to as the missing middle in robotics and how we use human-in-the-loop technology to shore up some of those 60K moments. I don't think we can hear.
We can't hear him just yet. Oh.
No, okay. 1 second, guys. I don't think you can hear it still, right?
Yeah, I can't hear it yet.
Nope.
All right, we're going to do closed captions.
Yeah.
So I'm sorry about this, everybody. What if I fast forward to this part and maybe someone can narrate it?
Yeah, I can talk over it a little bit here because I've watched this video a number of times. When I first joined Plus One, I thought this capability is actually pretty key to solving how to put AI vision systems in the wild. And so when Eric talks about the missing middle, there's a one-to-one relationship when it comes to like surgical robots, and when you're doing surgery on a person, right? But then when you do like a type of system that's like in automotive, you have a 1 person to 10,000 plus. And so this whole point is, there is a number of people that should help out with AI vision systems to ensure that they're doing work and the right work all the time. And so what is that magic number? And so for Plus One, this is where Yonder has come in and really the concept of human in the loop to ensure that we can optimize the number of people that are servicing our clients. So today, the goal is not to have for every one robot we have in the field, one person to oversee that. Really, the goal is to try and stretch that to as many as possible. And so again, talk about the missing middle. This person in the missing middle is our crew chief that is kind of overseeing our fleet of robots out there. And so the goal is to try and have 20 to 30 robots to one person, something along those lines, to ensure that the customers can always have an operation that works. We know that industrial robots previously had always worked because they're doing the same job over and over and it doesn't change, and you just do basic maintenance. But when you're doing a task that involves AI vision systems, sometimes you're going to run into that long tail item that is going to mess up your system. And that's where these crew chiefs, that's where this missing middle comes in to ensure that we can correct that mistake or correct whatever's going on in the cell and then continue with the operation.
Correct. Yeah, we use actual humans in the loop, as we say, to gap any time that the AI comes short of what actual peak performance would look like. Awesome. So now that we all kind of have like that context of what human in the loop is and how we essentially avoid downtime, let's kind of just talk more generally. So, John, I'm going to start with you today. So first question is, downtime often gets treated as an inevitability or a rounding error. Can you break down the real math behind the per minute cost of a stalled operation? And what should leaders, think about a little bit more often or maybe underestimate when calculating that number?
Sure. So the real math is pretty simple, and any operations area can kind of break this down for themselves. So when you pay for a logistics system or an automation system of any type, we all kind of know that when a sorter breaks down or something like that, you're costing money based on the number of sorts that are not happening through that main artery, right? And so a lot of customers already get this from their larger systems. The same is true from a robotic cell as well. So if you have a $250,000 robotic cell that every time it's doing a pick, it's offsetting your cost by, let's say 10 cents a pick, because that's what the math worked out to originally. If that is down for then 2 minutes, you can do the basic math that says, all right, 2 minutes times those 10 cents is some of that ROI. And of course, that's only during a small period. And so when you think of how many little pieces of downtime can happen when you have a 2 minute to 5 minute downtime for a robot cell, that can add up quickly. For us, we talk about this
Right.
$60,000 a minute. The way we can kind of help solve that was with what we talked about before, that missing middle. So we have this crew chief who sits, on plus one side of the business that can remotely access any of these cells and correct any errors that are happening to ensure that instead of it being a 2 minute or a 5 minute downtime, that's a 5 second or less downtime. And so instead of that costing you, again, that one piece that costs you 10 cents every time you do it, and you multiply that by the number of pieces you're missing in that hour, it's only going to cost you maybe one or two pieces, because we'll be involved to make sure it gets back to its automated cycle. So that's some of the math that it goes down to. Is instead of being down for 2 to 5 to 10 minutes, you're only ever down for 5 to 10 seconds.
Right. No, that makes sense. Ryan, as being somebody who's been in these production lines thinking about reducing downtimes and the cost of downtime, what are some of your thoughts on this?
Yeah, I think when you're looking at the cost of downtime, everybody focuses in on the system that's down. And, say you're paying $100 an hour, it's down for an hour, you lost out on $100, right? But
Right.
it's more than that. If this system is doing 2,000 packages an hour and you're down for an hour, and that 2,000 is now part of 10,000 that's going downstream, the people downstream are now less productive as you as well, as they should be as well. So instead of getting 10K, they're only getting 8K from the rest of the system because 2K is missing. And then that's going to extend your shift, extend overtime, all of that fun stuff. So I see that as being a big factor that a lot of people miss in this calculation.
Mhm.
And another reason why, when we're going through our cells and our systems and explaining Yonder and the human in the loop element, it's not that someone's just sitting there staring at your robot the entire time. When the robot doesn't know what it needs to do, it calls for a little bit of help. And, within 10 seconds, like John said, it's back up and running 99.5% of the time. There's going to be occasions where there's a package, set up on a guardrail that, the robot can't reach, and it's going to need a little bit of help from somebody in the operations. But, we try to limit that as much as possible.
Right. Yeah, I think it's very easy to hyper focus on the actual machine or piece of technology that is actually down, and not thinking about the cascading effect that bottleneck now created. So really good insight. Okay, so next question is going to be, let's start with Ryan. What are some factors that quietly erode throughput even in an otherwise high performing facility?
Yeah, there's a couple factors that in my time running operations and working with operators in the past that we really focused on it. And, one of them is exception handling, rejects, because that's a package that could have followed a quote unquote happy path through the facility that now has to be special handled and, take away from that overall throughput. There's ways to fix that, but most of that it's, one-off basis. A package came in, open, something like that. But the biggest one that we started to focus on in past lives was that micro starvation. And, we use that term a little broadly. Could be, unloading a truck and that trailer's empty and you have to spend 10, 15 minutes, swapping a trailer. And what that does throughout the entire facility and erode that, 15 minutes of, no packages going through adds up pretty quickly. Or it could be a robotic system that doesn't have volume for 30 seconds. And what does that do to your PPH downstream as well?
Right.
So those micro starvations, and every facility is going to be different, where they happen, why they occur. But trying to eliminate as much of them as possible is exactly, where we spend a lot of time focusing on.
Awesome. John, do you have anything to add there?
The only thing I would say is this is also part of the design process. I know in previous webinars, we've kind of talked about the design process, making sure you get things right up front.
Right.
Some of these micro starvations are sometimes caused by the design, and we know we have done that before previously. Plus One's been around since 2016. We're going to come into our 10th year of existence, and so we have a lot of experience in trying to design those out. But again, going back to this downtime we're talking about today, it's having all the tools possible to prevent that downtime to ensure operations are working all the time. So it's not just getting the right design in there. It's not just having a good AI system. It's not just a good, robot and gripper, but it's also
Right.
good software and all the long tail scenarios that you have to deal with.
Yeah, I think I would agree with you there. Okay, so let's move on to our next question. Let's start with John here. John, space is getting tight, especially in older facilities, and now leaders are watching throughput per square foot very closely. How should operators think about the value of a single minute when every square foot of the floor has a real cost associated?
The This is mainly going to be constrained to brownfields. I know for a lot of the greenfield facilities, they're designing this out, but we're seeing more and more folks that are asking us to come into their facilities and put in robotic systems where systems have been around for 10 or 15 years.
Mm-hmm.
So when I think of, how do we kind of make the throughput more efficient, it actually comes down to not just the throughput more efficient, but the total number of hours your building has to be operating divided by a total number of labor hours. And so automation systems, of course, the goal is to help out with that. It's to offset the number of labor hours in the facility, but also, and Ryan was hinting at this earlier, but to make things kind of flow more evenly throughout it, right? If you have these big old peaks you have in like a certain operational area, somewhere downstream has to absorb that peak too. And
Right.
getting back to the main topic of this whole webinar here is if you have downtime with any robot system, and again, this goes back to what Ryan said, that is going to permeate through the rest of the facility. And so if you have a receiving system that is supposed to operate, we'll say between 5 dock doors or 8 dock doors and do 10,000 pph, and it goes down for, we'll say it goes down to 8,000 pph for half an hour, that reverberates throughout the facility. And so going back to, how should operators, think about this, it's making sure you have enough systems in place, not just the people in place, but automation systems that are robust enough to operate through the variety of, things that a warehouse can handle, right? We always talk about long tail. And to me, the long tail is what basically makes or breaks automation systems in the warehouse.
Yeah, I think also, Ryan, I think based on your experience leading Epidney and UPS, I think this kind of parallels into our next question here. What are the ripple effects when downtime forces teams to compensate with overtime, right? And how should leaders quantify those second order costs?
Yeah, so there can be a wide-ranging effect when a system goes down, especially one that's critical, like John just said, of something on the dock receiving for you, a receiving system. If that impacts your entire facility's throughput for the day, you're either going to have to, one, push that volume to the next shift and force them to, run a little heavier, faster than they normally do, which brings in a bunch of issues and errors can occur, and people moving faster than they're supposed to can lead to safety issues. But if you just run to that overtime, you're going to see some bigger, like some issues around the fatigue. If you consistently do it day over day, folks are going to get more fatigued. If they're used to working 6 to 8 hours, now they're 8 to 10 or 10 to 12 in some scenarios. And then when you get fatigued, you see increased injuries and so forth. And then, if you're consistently running that overtime or those longer days because of downtime, people do have a life outside of work, right? So you're going to end up losing employees to turnover or to different jobs that are more consistent because they do want to have that life with their family outside of work, right? So, not only are you going to risk injury, risk some safety concerns, have lower accuracy, but you're also going to run that risk of, having your employees leave if it consistently happens. And you don't want to have that in today's market in general, just because how labor is so thin to begin with, and losing good employees because you're consistently running overtime or over their set schedule is going to cause major issues for you.
Right. Yeah. I mean, I would hate if I was getting called in at the end of every week, because on Monday we started having residuals. I'm getting called in to do overtime Friday and Saturday, sometimes even Sundays, right?
Yeah.
So, and going 2-3 days consistently over my schedule would drive me crazy. So I can only imagine people who are actually in these facilities. John, do you have anything to add to that?
Sure. I was even going to throw in, I mean, imagine not only is it unfortunate for folks that are having to do that mandatory overtime all the time, but imagine if you invested in an automation system and then you still have to do that mandatory overtime because that's not working because of again, these long tail issues with certain items, right? So again, this comes back to really when you're doing an automation system of any type, right? I talked about sorters before, right? I spent a long time at Dematic designing, sortation systems like that and ensuring, no downtime. But with, now with the advance of AI and robotics and vision systems, the same thing applies. You don't want downtime because as soon as you have more and more downtime, you extend your shifts, right? When you extend your shifts, people get overworked more. Then, as Ryan was saying, you're going to get folks that are like, why do I want to work this job versus another job? So an automation system that could avoid that downtime really can help be an employee retention facilitator as well.
Right, exactly. Yeah, I would assume that it's very similar to getting a new tool, right? Whenever you,
Yep.
if you've always used the manual method of punching in a nail with nail and hammer, and then one day you get one of those like nail guns, right? It simply just makes the job easier. And when there's a lot less slowing down for the operation, you'll see that effect throughout the building. Not yes, you installed it in one section of the building, but almost the entire operation is actually a little bit more alleviated. Okay, so that kind of brings us over to our next question. Ryan, I'm going to continue here with you. Most organizations still operate in a break fix mode. What does proactive downtime prevention strategy look like in 2025? And which leading indicators matter most?
Yeah, so when you take a look at these automation systems, they need maintenance. And you'd rather it be preventive than reactive. And I don't want to say most businesses, but a lot of businesses still operate in that reactive mode, just because they're not sure what to look at yet. So one of the big things that would make a good strategy is understanding your mean time between failure. So for part ABC, it usually breaks every 6 months. So at 4 months, 5 months, you should really start taking a look at that preventative maintenance for it. And to do that, though, everybody inside the four walls of that building, everybody who has something to do with that facility, if your corporate is sitting somewhere else, needs to be on board with being able to turn over that system, whether it's a sorter, a robotic arm, an AGV, whatever it may be, to the maintenance team to properly do preventive maintenance. And there's some daily PMs, there's some weekly PMs, there's some quarterly, twice a year, yearly, every couple of years, right? But understanding your mean time between failure will let you know when those maintenance needs to be done. And you need your operators to be able to turn that equipment over to get that completed so that you're not in the middle of your Christmas rush in a couple weeks from now getting orders to the planes on FedEx or UPS or whoever you're shipping with to get to the houses and your system goes down. So the biggest thing is understanding that mean time between failure and allowing your maintenance teams to do the work that you're quite frankly paying them to do and keep your systems up and running.
Yeah, I would say MBTF is mean time between failure. MBTF is a very important acronym for engineers, and especially in my background, who I've worked with, essentially maintenance prediction and life testing. The only thing that I can really vouch for, specifically at Plus One, is that anytime that customers are looking to install a brand new technology, a lot of these other companies, sometimes it might be their first real deployment. Sometimes the downside to having leading edge technology is that it hasn't been proven in a real world facility yet. And unfortunately for Plus One Robotics, we have had not only a great number of picks, but very kind of alluding to something here in my background, is the 1 billion picks mark, which just means we just have been running these machines for years at this point, right?
Yep.
Our maintenance schedules are based around that data. So one thing that I can always encourage customers when they're looking at and implementing new technology is to also take a little bit of the history of the company that they're working with. How many real deployments do they have? How many, whether it's picks, runtime hours, sortations, have these systems actually seen? Because you're right, the downtime is going to happen when you're handling these problems for the first time. Would you agree with that, John?
Yeah, I mean, there's no doubt that when you're doing a newer automation system, you got to make sure you know what you're doing, and also, I mean, even a support contract as well. So, not just plus one, but every business has this where you can, hire the team to kind of say, hey, be with us 24/7 to make sure that we can, it can be fixed.
Hmm.
I would also go back to something we revisited earlier, which is not just making sure there's no downtime via some of the software services that we have, but also in the design intention of a cell as well. You were mentioning the 1 billion picks that is in both of our backgrounds here, but I would even highlight these robot cells that you see in there as well. The gripper designs are actually very simple as well. I know a
Hmm.
lot of teams that are out there in the wild and a lot of grippers that are out there normally do multiple suction zones and have a lot of, I'll call it, very intelligent features on the grippers themselves. But sometimes that can be over engineering for our use case. So I know Plus One tries to stick with a single zone gripper that has a number of common cups so that if, again, talking about mean time between failures, if something does fail, there's common components throughout, and therefore you can grab any, single cup to replace any of the other cups on the head of it, right? And you don't have to worry about, a specific zone of a gripper going bad, something like that. So it's also not just in, hey, don't operate and break fix and make sure you're, you know, you can fix your components, but also on our side, making sure that we design a system that is very easily fixable for the maintenance team that's on site.
Exactly. Yeah. So again, making sure the equipment itself is easy to maintain, and two, that there's enough runtime in that with that system to have a proper maintenance schedule associated. Okay, let's move on to our next question. John, this is for you. If you could fix just one cost of downtime tomorrow, what would have the biggest ROI?
To me, it would have to be exception handling.
Hmm.
I think every operation knows that the majority of the time things operate pretty smoothly. And there is a small percentage that, this goes back to the Pareto effect, right? It's not even 80/20. It's probably more like a, 5-95 effect where a tiny
Mm-hmm.
amount of things cause all of your downtime. And so to me, it's how do you solve for those pieces? And I think today we rely a lot on people to ensure that, like for instance, something that we deal with today is you have a package that is kind of taped together with another package. A person has to separate that out, right? But if
Right.
you're using a software system, then how do you solve that problem, right? And so we have experience kind of solving for that. So I would say, to me, cutting out exceptions as much as possible. That's what I would do first. And of course, when it comes to automation systems, you really got to focus on those because we depend upon people today to solve all those exceptions manually.
Right. And I guess, okay, so let's say that you wanted to get rid of exception handling. Um, what is one of the fastest ways that companies can take action for that quick payback?
Yeah. Um, I would say, I mean, of course, we're talking today about, a human in the loop to try and help with some of those downtimes for automation systems.
Hmm.
But the other big thing before even companies, have, robotic systems or even, like sorter and conveyor systems is just having, consistent operations. We mentioned this before about, ensuring you have a workforce that's there every single day and shows up. I don't need to tell this to any operations team, right? They know that they have experienced people, they can depend upon them, and it's
Hmm.
about not causing them burnout. And so the question is whether you could do that, with automation or without. I think we, of course, we're somewhat we would of course argue that automation can help out a lot when you
Hmm.
assist the operators in what they're doing and make their workflow a lot smoother and have a full system that can approach, solving, we'll say, like depalletizing, ensuring that you can get every type of pallet, every type of item off of there. Having that dependable system actually helps your operations and helps you retain people. And so to me, again, outside of the technology piece, it's, how do you maintain that workforce all the time? I think that's the next thing I would say. If we could fix that, that'd be really great. And whether automation is part of that or not, we're happy to talk with any company about that.
Right. No, that makes sense. Okay, let's move on over to our next question. This one's going to be for Ryan. Okay, given rising labor costs and ongoing shortages, how is the financial impact of downtime changing? What risks or inflection points should operators be planning for now?
Yeah, I think this is pretty straightforward, Jose, right? Like everybody's labor cost is increasing year over year. My last 4 years at Pitney Bowes, I'm pretty sure the labor rate increased 10% year over year,
Mm,
very rapidly, right? Not only did you have the uh, COVID-19 and the pandemic, but
yeah.
just also just everything going on in the world as well, and the cost of living increasing that, labor rates had to increase to get labor in the door. So, anytime there's a little bit of downtime. It's just going to cost more and more as we drive forward, which, is good and bad, right? It'll allow folks to put more automation in to, drive that labor rate down. But also that automation needs to work, and it needs to run the way it's supposed to, 99.9999% of the time. Which,
Right.
if we go back to what Plus One's doing, Yonder helps keep you in that up stage, fixing issues as they come up, and the robot calls for help right away instead of pausing and sitting idle for 5 to 10 minutes. But I really do think that operators, businesses now just need to be looking at where automation makes sense, not only today on December 3rd of 2025, but where does it make
Right.
sense December 3rd, 2027 and 2029, right? You have to start planning, your next 5 years at the labor rate that we're growing and that clip that we're seeing.
Yeah, I mean, you never know when the next, pandemic or surge in orders might come from, whether it's environmentally induced or politically induced, or even just we've seen, trends are very big these days. So all it takes is Taylor Swift dropping another album, and now you have an influx of, her brand of makeup or something like that. And you're right. You don't know what you don't know. So the best thing you can do is be preventative and almost take the history that you have, see the trend that where it's going, and project it over, like you said, 1, 2, 3, 5 years, and start installing the technology so that the not just one area of your building is automated, but the entire process, right? The biggest slowdown to a robotic system is usually coming in from the upstream and the downstreams that haven't been automated just yet. So very, very good points. Okay, so
I'll say one thing I'll add to that too is because what you kind of mentioned, Jose, about an inflection point, and I don't think anybody wants to get to the point where they say, "Oh shoot, now I have to automate," right? So I think we're getting a lot of companies, and Plus One's been around long enough that we have customers that do a project with us. We do bidding, we do all the quotes that needs to happen, and then the project sits on the shelf for maybe a year and a half to 2 years, and they come back, and because they've done that work already, they can come back and get launched pretty quickly, right? So I would encourage anybody, right, operations teams, the automation teams out there and the innovation teams to talk to us and your integrator partners to really kind of start to learn what's out there today, especially between now and, we're going to have, our trade shows next year in March, to learn what's out there so that you're not caught flat-footed when you hit that inflection point.
Yeah, exactly. I think it's something I take a lot of pride in our company, is that we are very quick to say, hey, you may want a robotic system that can do, 2,500 picks per hour, 3,000 picks per hour. But unfortunately, your systems, your upstream and downstream systems are just not up. They're not going to be able to even feed that flow or receive that kind of flow. So we will work with you so that you can also reach out to our partners that help with some of these upstream and downstream portions of the system. So yeah, really good point, John. Okay, great. We've reached our last question. So this one is going to be for both of you. If you want, John, you can go first unless you guys want to reach for the buzzer. But for leaders who want to get a handle on the true cost of downtime and build a roadmap to reduce it, what are three? I want three actions actions or measurements that people watching this video or watching the recording can start with today. No budget approvals needed. Just give me 3 practical actions to start reducing downtime.
John, you want me to go or you want to go?
You can go first. Go for it, Ryan.
All right, yeah. So the 3 biggest are: understand your true labor costs in the facility. I think everybody should already know that. But then understand that mean time between failure that we talked about earlier, and put a PM schedule in place that gets the preventative maintenance done before that average time of failure occurs. Having that schedule in place and completing that schedule will automatically eliminate 50 to 60% of the downtime issues that you see very rapidly, very quickly, without spending a lot of money or spending any money whatsoever, right? So Just understanding what your full labor cost is so you can convey to your leaders and your operations team, every minute of downtime cost X. Facility that I used to work in, every 10 minutes was $1 million, right? So understanding that number, and you could drive into understanding when the PM schedule putting that PM schedule together, knowing the mean time between failure, and then completing those schedules or completing the PMs on that schedule to prevent those downtimes.
Right. No, that makes sense. So MBTF, PM schedules, and actually completing the PM schedules. I like that.
Correct.
Very, very actionable items. Thank you, Ryan. John, okay, over to you.
Sure. I would say this is revisiting a number of things we mentioned before, but the first one on my mind is your churn or your employee turnover. I think most people will know that either offhand or can figure it out decently quickly. And again, as you're saying, no budget approvals needed. So, how often is your workforce turning over? And then that can help to, you can learn, what you need to change in your process to make sure it doesn't happen anymore. I would also look at your previous automation projects. It can be as small as, all right, well, we got a new fork truck in. How often are we using this, right? Or it can go down to like a sorter, things like that. Or some companies have dipped their toes into robotic systems, and what is the actual ROI versus what you assumed at the beginning of that. Again, I don't think that requires any approval. It just requires looking back at what you thought it was supposed to be, and then what it looks like now. And then the last thing I would say is the utilization of your workforce itself. I know a lot of people can look at this, but when you have like what I think of as downlines for manual palletizing, you can kind of look out to your downlines and say, all right, how often are my workers actually doing the work there, or maybe walking to different pallets to do that work? And of course, you can also look at your stats at the end of the day, saying how many items sorted were there, and how many hours did it take for people to do that. And again, I think those are all things you can look up today just to see, is there something that we can improve upon either with, process improvement or with automation. But again, all those things I don't think, you need a budget approval for.
Yeah, no, I like that. So, kind of like, I like how your stats are a little bit more like indicators of a bigger problem. It's kind of like you said, 1, churn and turnover, 2, utilization utilization per hour of the technology that you have installed if you have some already. And then 3, take a look at what you assumed your ROI was going to be when you first started the project and what it actually is. 1, 2, 3, 4 years later after installation. I like that. Okay, so let's kind of start wrapping it up here. We are at the end of our session. For those in the audience, is there any questions that you would like to share? Please post them in the chat if you have any. I think Lisa, let me know if there was any questions in the chat. No, right?
I didn't see any today. No.
That's okay. Okay. Thank you, guys. This has been really insightful. Thank you both for your time and the overview, gentlemen. As a reminder for everyone in the audience or watching this video in the recording, you can get a copy of the webinar via email that will be getting shared with you if you attended today. And that does it for us for 2025. I hope that everyone has a good peak season, happy holidays, and enjoys a little time off. We'll be back at our regularly scheduled date, the 4th Thursday of the month, to discuss fashion meets fulfillment, automating apparel induction the smart way. This time with guest speaker Chris Caldwell from Yaskawa. So make sure to check out our webpage for the Season 2 schedule and more details about our upcoming webinars. Okay. And if you have any questions following today's webinar or want to discuss more about +1 Robotics, please reach out to me or Lisa and we can connect you to either one of our speakers. Feel free to add them on LinkedIn. Feel free to add me on LinkedIn. We love to talk tech, talk logistics, and always happy to start up a conversation. So definitely look out for us there. Thank you, everybody. Happy holidays, everyone. And I'll see you in 2026.
All right. Thanks, Jose.